Hello everyone, welcome to Ship's Chemistry classes. Today's topic is chemical bonding and this is the second chapter of your class 10th ICSE Chemistry. So before coming to the main topic, we should know why we have to study this chapter. What is the need to study chemical bonding? See, I'm going to write some examples over here like NaCl, HCl, H2O, CaO, H2SO4, so many compounds are there. Some are artificially prepared in the lab and some are naturally occurring. See, I have written some of the very common examples. You are already familiar with these examples like sodium chloride. This is the common salt, or the salt which we eat. HCl is the hydrochloric acid. H2O, everyone knows, water, calcium oxide, and this is sulfuric acid. Okay, if you give a close look to these compounds, you can see that these compounds are formed by the combination of some elements. And like in this sodium chloride, two elements are combined like sodium and chlorine. This is hydrogen and chlorine. This is hydrogen and oxygen, calcium and oxygen. And here hydrogen, sulfur and oxygen, three elements are there. So you can see compounds in which two or three or four elements have combined together and they form a compound. And these compounds which are formed, they have entirely different properties than its constituent element. Like if you take sodium and chlorine, sodium is a soft metal and this chlorine is a gas. We all know that chlorine is a gas. So when they combine, they form sodium chloride. They're chemically combining and they're forming sodium chloride, and this sodium chloride is a solid, crystalline solid, and this is edible. But if separately we see, they're not edible, but after combination they become edible, we can eat that. So whatever compound is formed, they are entirely different from its constituent. But the question that comes to our mind is why these elements are combining. What is the need for this element to combine? So the question that comes is why the elements combine. If you recall your previous chapter, periodic table, in which we have studied about group 18 elements, we have studied about group 18 elements. What are they? We call them noble gas, or we call them inert gas, and examples are helium, neon, argon, krypton, xenon, radon. So these are the group 18 elements or noble gas or inert gas. ठीक है, ये helium है, neon, argon, krypton, xenon, radon. Why they are called noble gas? Why they are inert? Because they are either least reactive or non-reactive at all. But why so? Because they have their octet complete. They have valence shell complete with 8 electrons. The valence shell, like except helium, and helium has 2 electrons, only 2 electrons. That is its duplet. Duplet is complete. Rest all, neon atomic number is 10. If you look at the configuration, it is 2 and 8. See 8 here. Okay. Similar is the case with every. All the elements, they have 8 electrons in the valence shell except for helium, because helium has 2 electrons. This has its duplet complete and rest all the elements have their octet complete. So because of their complete octet, they are either inert and they are non-reactive or least reactive. You can see very rare examples of rare compounds of inert gases. Okay. So my question is why the elements are combining, why they have the tendency to combine. Because all the atoms of the elements, they want to complete their, either they want to complete their duplet or octet. Means they wants to have 8 electron in their valence shell to complete octet, है ना. सबको सब एलिमेंट्स को क्या चाहिए है? They wants to complete, they wants to have 8 electron in their valence shell, and some are having either more than 8 electrons or some are having less than 8 electrons. So those who are having more than 8 electrons, they will lose electron, and those who wants to gain to complete 8 electrons, so they will gain. ठीक है, so to do so, what? To complete the octet और डुप्लेट भी हो सकता है, ऑक्टेट भी हो सकता है, 2 इलेक्ट्रॉन भी हो सकता है, 8 इलेक्ट्रॉन भी हो सकता है, 2 होगा तो भी कंप्लीट है, इनर्ट है, और 8 होगा तो भी कंप्लीट है. सो ऑल द एलिमेंट्स वांट्स टू डू सो, है ना. सो टू कंप्लीट द ऑक्टेट और डुप्लेट दे कंबाइन. और ऐसा करने से उन्हें क्या मिलेगा? टू अचीव स्टेबिलिटी, टू गेन or achieve stability. Means why the elements are combining? They are combining to attain the duplet or octet configuration to become same as the noble gas, and they want to achieve stability or they want to become inert, है ना. सबको स्टेबल होना है, तो स्टेबल होने के लिए ही ये केमिकल कॉम्बिनेशन होता है. ठीक है, अब केमिकल कॉम्बिनेशन होगा कैसे? हाउ दिस केमिकल कॉम्बिनेशन विल टेक प्लेस? नेक्स्ट क्वेश्चन इज हाउ केमिकल कॉम्बिनेशन टेक्स प्लेस, है ना. हमने बोला कि एलिमेंट्स कंबाइन हो रहे हैं केमिकली, दे आर कंबाइनिंग टू अटेन स्टेबिलिटी. नाउ द नेक्स्ट क्वेश्चन दैट कम्स टू आवर माइंड इज हाउ दे आर अटेनिंग, हाउ दे आर केमिकली कंबाइनिंग. सम मेथड वुड बी देयर. Some method would be there by which these elements are chemically combining. So that method is the rearrangement of electrons, है ना. Rearrangement means some elements will gain electron and some elements will lose electron. In this way they rearrange their electrons to attain the stability. ठीक है, now we are coming to the main topic, and that is how this rearrangement take place. How this rearrangement take place? Rearrangement of electrons. Let me put some ink in my marker because it is not working. So the next topic is rearrangement of electrons. So the first method by which rearrangements take place is by losing electron. Generally, metals used to lose electron. We know this. We have already studied this in periodic table chapter that metals has the tendency to lose electron because they have either 1, 2 or 3 electron in their valence shell. है ना. So because they are having 1, 2 or 3 electrons in their valence shell, so they lose electrons and they give the electron to the non-metal because non-metals are electron acceptors. ठीक है, so in this way the first method is losing electron or giving up electron, and in this type of rearrangement what types of bond are formed? Electrovalent bond. Or we can call them ionic bond. So in the first method electrovalent bond is formed. Second is sharing. By the name itself, we can get the idea that sharing between the atoms of the combining element is taking place. Sharing of electron is taking place between the combining elements. The sharing can be 1 pair of electron or 2 pair of electron or 3 pair of electrons. So this we study separately. Just get a simple idea that in the second method of rearrangement, sharing of electron take place, and in this method, the bond that is formed is called covalent bond or molecular bond. And the third is electron pair is donated by one atom. Means during the chemical combination, one atom it donates the electron pair. Okay, so in this type of rearrangement, the bond that is formed is called coordinate bond. Or we can call them dative bond. So these are the three ways by which the rearrangement of electrons take place between the atoms of the combining element during the formation of a compound. Alright, so now we are going to study them separately. First, we will see what are electrovalent bonds. Those who want to take the screenshot, they can do so. So now put the heading electrovalent bond. Electrovalent bond. We have already discussed that electrovalent bond is formed by the donation of electron. है ना? So the bond that is formed by the loss of electron from atom of one element and gain of electron by the atom of other combining element. This will become more clear with the help of example. Like we'll take the formation of sodium chloride. Sodium atomic number is 11. Chlorine atomic number is 17. Its configuration is 281 and this is 287. So by the configuration it is clear that sodium will give one electron because it has one electron in its valence shell. So it is difficult to accept 7 electron. Is it so? What this sodium will do? Will it donate this electron, one electron, or it will take 7 electron to attain octet? No, definitely it will give this one electron. So sodium loses this one electron and form sodium ion, a positively charged ion that is called cation. And this chlorine, this will accept this electron and form negatively charged ion that is called anion. What is happening? Sodium is donating its extra one electron to complete the octet. If it gives its one electron, it will gain the electronic configuration similar to neon. We know the atomic number of neon is 10 and its electronic configuration neon का क्या होता है? Neon atomic number 10, configuration 28. So क्या होगा यहाँ सोडियम को, सोडियम आफ्टर गिविंग दिस वन इलेक्ट्रॉन इट विल गेन द इलेक्ट्रॉनिक कॉन्फिगरेशन सिमिलर टू neon and it will complete its octet and become stable. And chlorine, it will accept this electron and it will become 288. After accepting, what it will become? It will become 288. इसका भी octet complete हो गया. So both are satisfied, both are happy now. So in doing this, a force of attraction develops between them. है ना? When they are rearranging their electrons, when they are chemically combining, a force of attraction, develops between them. है ना? So this force of attraction is called electrostatic force of attraction. Electrostatic force of attraction. है ना? So that is why it is called electrovalent bond. We have already written the definition that it is formed by the loss of electron. One atom is losing, another atom is gaining. Why this is positive and why this is negative, this we have already studied in first chapter. फर्स्ट चैप्टर में हम डिस्कस कर चुके हैं कि इसमें पॉजिटिव चार्ज क्यों आता है और इसमें नेगेटिव चार्ज क्यों आ रहा है. और यहाँ पे जब लॉस एंड गेन ऑफ इलेक्ट्रॉन इज टेकिंग प्लेस, तो द वन विच इज लूजिंग इलेक्ट्रॉन इट फॉर्म cation which is positively charged species, and the another one which gains electron it will form anion, that is negatively charged species. So that is why ions are formed. That is why it is also called ionic bond. This much is clear. So why this is called ionic bond? Because ions are getting formed over here. Positive and negative charged species are formed. So these are called cation and anion. So that is why it is also called ionic bond. So there are some conditions that are necessary for the formation of इलेक्ट्रोवैलेंट बॉन्ड. है ना? कुछ कंडीशन होते हैं जो फेवर करता है फॉर्मेशन ऑफ इलेक्ट्रोवैलेंट बॉन्ड. सो नेक्स्ट हेडिंग यू हैव टू पुट कंडीशन फॉर द फॉर्मेशन ऑफ इलेक्ट्रोवैलेंट बॉन्ड. Conditions. First is low ionization potential value. Low ionization potential value. अब ये क्या होता है ionization potential? We have already studied this. It is the amount of energy needed to remove electron from the valence shell. है ना? कुछ एनर्जी लगेगा इलेक्ट्रॉन को रिमूव करने के लिए, तो दैट एनर्जी इज कॉल्ड आयनाइजेशन पोटेंशियल. तो मेटल्स वी नो दैट दे हैव द टेंडेंसी टू लूज इलेक्ट्रॉन, तो उसको कुछ एनर्जी देना पड़ेगा इलेक्ट्रॉन को रिमूव करने के लिए. तो एनर्जी कितनी होनी चाहिए? कम से कम होनी चाहिए. है ना? इट शुड बी मिनिमम. जितना कम होगा उतनी ही आसानी से इलेक्ट्रॉन रिमूव हो जाएगा. तो हमें आसानी से इलेक्ट्रॉन रिमूव ही तो करना है ना. वी वांट टू रिमूव इलेक्ट्रॉन इन द फॉर्मेशन ऑफ इलेक्ट्रोवैलेंट बॉन्ड. सो दिस आयनाइजेशन पोटेंशियल वैल्यू शुड बी लो. ठीक है, ये लो होना चाहिए है. सेकेंड, हाई इलेक्ट्रॉन एफिनिटी वैल्यू. नाउ नेक्स्ट इज इलेक्ट्रॉन एफिनिटी. इलेक्ट्रॉन एफिनिटी क्या होता है? द अमाउंट ऑफ एनर्जी रिलीज्ड व्हेन इलेक्ट्रॉन इज एक्सेप्टेड बाय एन एटम. है ना? जब इलेक्ट्रॉन एक्सेप्ट हो रहा है तो डेफिनेटली इलेक्ट्रोवैलेंट बॉन्ड के फॉर्मेशन में अगर if one is donating the electron तो another one should be there to accept that electron. और वो इलेक्ट्रॉन कौन एक्सेप्ट कर रहा है? वो इलेक्ट्रॉन नॉन मेटल्स एक्सेप्ट करते हैं. है ना? क्योंकि नॉन मेटल्स हैज द टेंडेंसी टू गेन इलेक्ट्रॉन. और जितना ज्यादा एनर्जी वो रिलीज करेगा मतलब उतना खुश हो रहा है वो इलेक्ट्रॉन को पाके. है ना? इलेक्ट्रॉन को पाके जो खुश हो रहा है, सो दैट एलिमेंट इज रिलीजिंग मोर एंड मोर अमाउंट ऑफ एनर्जी. तो what condition will favor in terms of electron affinity? That electron affinity value should be high. Third is large electronegativity value. Large electronegativity difference. है ना, कंबाइनिंग एलिमेंट्स के बीच में इलेक्ट्रोनेगेटिविटी का डिफरेंस भी ज़्यादा से ज़्यादा होना चाहिए. वी नो दैट ग्रुप 17 एलिमेंट्स आर हाईली इलेक्ट्रोनेगेटिव. ग्रुप 17, तो हमने अभी जो एग्जांपल देखा सोडियम क्लोराइड का, सोडियम कौन से ग्रुप का है? सोडियम बिलोंग्स टू फर्स्ट ग्रुप. वी हैव स्टडीड ना लिथियम, sodium, potassium, rubidium, cesium, francium. In the first chapter, see, you have to learn at least up to 30 atomic number 30, है ना. शुरू के 30 एलिमेंट्स तो आपको लर्न करना ही होगा. ये ग्रुप 1 एलिमेंट है, दे आर मोस्ट इलेक्ट्रोपॉजिटिव. हाँ, एक इलेक्ट्रोपॉजिटिव कौन होता है? जो इलेक्ट्रॉन दे रहा है ना, लाइक सोडियम प्लस चार्ज, उसके ऊपर प्लस चार्ज है, इट इज फॉर्मिंग कैटायन, दैट मीन्स इट इज इलेक्ट्रोपॉजिटिव. सो दे आर मोस्ट इलेक्ट्रोपॉजिटिव एलिमेंट्स. Who? The one that is belonging to group 1. And group 17 halogens, they are also called halogens. फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन, है ना. ये क्या है? ग्रुप 17 एलिमेंट्स है. दे आर द मोस्ट इलेक्ट्रोनेगेटिव एलिमेंट्स इन द पीरियोडिक टेबल. व्हाट इज इलेक्ट्रोनेगेटिविटी? द टेंडेंसी टू अट्रैक्ट द शेयर पेयर ऑफ इलेक्ट्रॉन, है ना. दैट इज टेंडेंसी. उनकी टेंडेंसी होती है कि वो इलेक्ट्रॉन को अपनी तरफ खींचते हैं, है ना. इलेक्ट्रॉन एफिनिटी क्या होता है? एक्सेप्ट ही कर लेते हैं, बट ये अट्रैक्ट करते हैं. इलेक्ट्रोनेगेटिव एलिमेंट वो होते हैं, दे हैव द टेंडेंसी टू अट्रैक्ट the shared pair of electron. It will become more clear when we study the second type of bonding. Covalent bond में और अच्छे से क्लियर हो जाएगा कि इलेक्ट्रोनेगेटिविटी क्या होता है. ठीक है, तो अभी आपको इतना समझना है कि इन द फॉर्मेशन ऑफ इलेक्ट्रोवैलेंट बॉन्ड लार्ज इलेक्ट्रोनेगेटिविटी डिफरेंस शुड बी देयर. ठीक है. ग्रुप 1 एलिमेंट्स जनरली ग्रुप 17 एलिमेंट्स से दे कंबाइन एंड फॉर्म कंपाउंड्स बिकॉज ऑफ लार्ज इलेक्ट्रोनेगेटिविटी वैल्यू डिफरेंस. So these are the conditions. See, you will get questions from these, है ना, कि पूछ सकते हैं कि why sodium combined with chlorine, है ना, कितनी जल्दी सोडियम क्लोराइड कैसे बन जाता है, why it favors the formation. So you should know that due to the large electronegativity difference, sodium being the more electropositive element, it combine easily with the more electronegative element, so they form compound easily. So these type of questions you will get in reasoning type. All right. So these are the condition that favors the formation of electrovalent bond. Now we will take one by one examples of electrovalent bond. Periodic table सबको याद करना है. सबसे पहला एग्जाम्पल हम लेंगे सोडियम क्लोराइड. Will go according to your book because it will be easier for you to study then, है ना. सबसे पहला एग्जाम्पल है सोडियम क्लोराइड. सोडियम क्लोराइड तो हमने ऑलरेडी कर लिया है, फिर भी एक बार करते हैं. सोडियम एटॉमिक नंबर 11, कॉन्फ़िगरेशन 281, lose 1 electron, form sodium cation, chlorine 287, gain this electron and form an ion. ठीक है. So this is cation, this is anion. And during this combination, an electrostatic force of attraction develops between them and they form electrovalent bond. We'll see the Lewis dot structure also. क्या होगा? Na plus Cl gives NaCl. Lewis dot structure क्या होता है? Lewis dot structure. What is Lewis dot structure? In Lewis dot structure, we only show the symbol along with the valence shell electron. Like hydrogen, we know its atomic number is 1, so it has only 1 electron. This is the symbol of hydrogen, and we will show the electron like this. Chlorine का अगर show करना है तो chlorine we know it has 7 electron in its valence shell, so we will show 7 electrons only. Inner orbit electrons को हम show नहीं करते हैं Lewis dot structure में. ठीक है. सो सोडियम क्लोराइड का लुईस डॉट स्ट्रक्चर कैसे बनेगा? सोडियम 1 इलेक्ट्रॉन इन इट्स वैलेंस शेल, क्लोरीन या तो हम डॉट से रिप्रेजेंट कर सकते हैं, क्रॉस से रिप्रेजेंट कर सकते हैं, सर्कल से रिप्रेजेंट कर सकते हैं. तो they combine and form ऐसे शो करते हैं इसको. This is the Lewis dot structure of sodium chloride. Next we will see magnesium chloride. You put the heading, I am coming within a second. Alright, so next example is of magnesium chloride. मैग्नीशियम क्लोराइड का एटॉमिक नंबर मैग्नीशियम का क्या होता है? मैग्नीशियम एटॉमिक नंबर इज 12. Again chlorine, atomic number is 17. Configuration will be 282, gives 2 electron and forms Mg2 plus. Why Mg2 plus? Because this 2 plus shows that it has given its 2 extra electron. Chlorine, so 2 electron donate कर रहा है तो 2 chlorine will be present here. 2 chlorine accepted this 2 electron and forms 2 Cl minus. This 2 shows that 2 chlorine are present, and this minus shows that 1 electron is accepted by both the chlorine atom. They combine ठीक है. अब इसके पास क्या हो जाएगा? Configuration will become 2 8 and this will become 2 8 8. So stable. This is also stable, this is also stable, and they form magnesium chloride. Okay, clear? Lewis dot structure कैसे बनेगा? Magnesium 2 electron, two chlorine atoms are there. एक इलेक्ट्रॉन इसके पास जाएगा, एक इलेक्ट्रॉन इसके पास जाएगा. ठीक है, and it will form Mg2 plus 2Cl fine. Take the screenshot of this. Next we will see the example of calcium oxide. Next is calcium oxide. Calcium atomic number is 20. Atomic number 20 and oxygen 8. So this much is clear. Calcium's atomic number is 20, oxygen 8. Calcium, if you see the configuration, it is 2882. That means 2 electron extra in the valence shell. So again, if we give 2 electron and form calcium 2 plus. Oxygen 2 6. Total of 8 electron. Configuration is 2 and 6. That means it is short with 2 electron to attend the octet configuration. This will accept this 2 electron and form O2 minus, and its configuration will become 288, and this will become 2,8. So both are now a stable species, this cation and this anion both are stable now because both have configuration similar to noble gas. Okay, and they combine and form the compound. After combination, what compound is formed? Calcium oxide. Now we'll see the Lewis dot structure of calcium oxide. Calcium 2 electron plus oxygen, 7, 8. See, it is having 2 electron extra, and one electron is donated to oxygen. That means oxygen is accepting the extra 2 electrons given by the calcium, and it has formed calcium oxide, which is a stable compound now. Okay, this much is clear. See, one more thing is there, oxidation and reduction. I'll explain you here only because it is already given in your syllabus. What is oxidation and what is reduction. We are again and again saying one thing, that electrovalent bond is formed by the loss of electron. And if we see this example here, we can see that this calcium is losing electrons. So loss of electron is called oxidation. So in this example, which species is getting oxidized? Calcium is getting oxidized because it is losing 2 electron, and I have said that loss of electron is oxidation. And if there is loss of electron, so there must be gain of electron also. So the gain of electron is called reduction. Loss of electron and gain of electron. Okay. So here calcium is getting oxidized and oxygen is getting reduced because calcium is losing electron and oxygen is gaining electron. So loss of electron is called oxidation and gain of electron is called reduction. And in electrovalent bond formation, both the process is taking place simultaneously. And here oxidation is happening and the another species that is accepting the electron. So definitely reduction is also happening. So in this particular bond formation, both the process is taking place simultaneously. So if it is happening like this, है ना, दोनों प्रोसेस एक साथ हो रहा है, तो वैसे रिएक्शन को, दैट टाइप ऑफ रिएक्शन इज कॉल्ड redox reaction. So what are redox reaction? The reaction in which oxidation and reduction is taking place simultaneously. So this much is clear to everyone. So in this electrovalent bond, the last topic that we have to study is the properties of electrovalent compounds. इलेक्ट्रोवैलेंस कंपाउंड्स की क्या प्रॉपर्टी होती है? Properties of electrovalent compound. First, they are solid. They are what? They are solid. हमने एग्जाम्पल देखा था सोडियम क्लोराइड. We have seen the example of calcium oxide, and also they are hard solid. So as they are why they are solid? Because they have a very strong electrostatic force of attraction. Electrovalent compound are formed by the combination of positive and negative ions, है ना? When positive and negative ions are combining, they develop a very strong electrostatic force of attraction between them. So उस इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन की वजह से जो उनकी जो कॉन्स्टिट्यूएंट पार्टिकल होते हैं दे कम वेरी क्लोज टू ईच अदर, और वी नो दैट इन सॉलिड कॉन्स्टिट्यूएंट पार्टिकल्स आर क्लोज. जिस भी कंपाउंड में, जिस भी मॉलिक्यूल में constituent particle closely packed होते हैं वो solid होते हैं. So similar is the case with electrovalent compound. Due to the electrostatic force of attraction between the oppositely charged ion, they are solid, है ना? तो अगर वो solid है तो definitely they will have high melting and boiling point. इनका melting and boiling point क्या होगा? high melting point and boiling point. क्यों? क्योंकि they are closely packed, so you have to supply lots and lots of energy to break that attraction, है ना? So they're definitely high melting and boiling point होगा. और in solid state they don't conduct electricity, है ना? In solid state they don't conduct electricity. सॉलिड स्टेट में वो कंडक्ट इलेक्ट्रिसिटी को कंडक्ट नहीं करते हैं. क्यों नहीं करते हैं? ड्यू टू द लैक ऑफ फ्री आयंस. इलेक्ट्रिसिटी कब कंडक्ट होता है ना? इलेक्ट्रिसिटी कंडक्शन टेक प्लेस ड्यू टू द प्रेजेंस ऑफ फ्री आयंस. जब फ्री आयंस मूव करते हैं तब इलेक्ट्रिसिटी कंडक्ट होता है. तो हियर वी आर सेइंग दैट दे आर वेरी हार्ड सॉलिड, so they lack free ions. So when they lack free ions, they don't conduct electricity in solid state. But in molten state, they conduct electricity. In molten state, they conduct electricity. Like NaCl, if you see NaCl, ये solid state में इलेक्ट्रिसिटी को कंडक्ट नहीं करता है, लेकिन जब हम उसको मोल्टन स्टेट में कन्वर्ट करते हैं, उसको हम डिजॉल्व करते हैं पानी में, एक्वा स्टेट में कन्वर्ट करते हैं, तो इट विल कंडक्ट इलेक्ट्रिसिटी. So this is all about the first type of bond, that is electrovalent bond. अब नेक्स्ट वीडियो में हम देखेंगे कोवलेंट बॉन्ड. Till then, bye bye.